Hey everyone, welcome back to DCC Workbench for part 6 of the Santa Fe locomotive upgrade. If you haven't seen parts 1 through 5, go check them out. I cover a lot of cool stuff like LEDs, the inner workings of the cab, ground lights, stair lights, wire management. I even installed a speaker with some other fun surprises. In this episode, we're diving into the decoder that I'm using for this project. If you're enjoying the build, subscribe, hit the notification bell. Let's get started with part 6. Alright everyone, it's decoder configuration time. I'm going to do an intro here. I'm going to start off by opening up the decoder from ESU. This is a LokSound 58821. It's designed to replace the factory light boards in a wide range of makes and models, including Atheron, the unit we're upgrading in this series. Inside the package, you'll find two pieces. The smaller one is the actual decoder. It's the brains of the outfit. The larger one is the adapter board, which connects the decoder through a built-in connector. We'll get into that in just a second. As we take a closer look at the decoder itself, this is where all the sounds and the commands live. Now grabbing the main board, the one with all the gold-looking pads, this is where I'll connect the wires for the lighting, the motor, speaker, and any other electrical connection. These two boards snap together using what is called a Next 18 interface, meaning the connectors have 18 pins that connect to each other. Each pin channels the functions like the track power, the motor control, lighting, and auxiliary functions. And yes, the speaker too. For those of you out there wondering about all the shapes and sizes of some of these connectors, you're not alone. Here's some material for you. The Next 18 interface uses the NEM 662 standard. The standard was developed by MOROP, which is the European Union of Model Railroad and Railroad Fans. Hey Canopy, nope, sorry man. There's no glue allowed for this part of the series. What are you doing here anyways? I thought you were still on vacation. Oh, I see. Well, I thought I mentioned in part 5 that you were banned from traveling for that exact reason. Remember that one time in Mexico? Okay, I'll drop it. So I'll just get back to the video then. How about you just try to enjoy the rest of your time off? Testing the decoder before installation. I always test each decoder out of the box before I do anything with it. When I run my test, I do this using a procedure that involves a testing stand that the decoder connects directly to. I just want to highlight that this decoder part of the series is not intended to cover all the hand cranks, bells, and whistles, or the more advanced decoder steps. But if you're interested in something more in-depth, subscribe and hit the notify bell. I'm currently working on a video covering more detailed setups, including important configurations for speed matching. For those of you who are new to DCC decoders or don't make a living in the technology world, these decoders are essentially little mini computers that use computer data. In the computer world, this is known as ones and zeros or on and off. Anytime we work with computer data, it is essential that the connectivity is solid for a successful transmission. Sure, Canopy, let me help you out. I know there's some confusion if we can program these decoders already installed in the locomotive and sitting on the rails, or if we should pull the decoder outside of the locomotive like I have here. So Canopy, to answer your question, should we program the decoders on the rail or with a testing stand? The answer is yes. Okay, let me explain. There are only two types of uploading to the decoder. There's the very small upload and a very large upload. The very small upload is when you program a change to the decoder like a road number, or change the speed of the motor, or adjust the brightness of the lights. Any change that is not replacing a sound. Then you have the very large upload. This is when you would change the sounds that are on the decoder. An example of this is replacing a bell or a horn sound, or the entire sound file. Most decoders are incapable of changing sounds, so most decoders only go through the small upload. I think you're getting it, Canopy. Since we're uploading an entire sound file and changing all the sounds, we are testing and making the changes to the decoder on the testing stand through the programmer and tester appliance. I am not going to ask how you know that. Yes, for the smaller uploads, the onboard error detection data byte that is built into the decoder standards does protect the smaller uploads against corruption, which is why small uploads on the track is considered low risk. That's right. For changing sounds, that's a different story. I've successfully uploaded and changed many entire sound projects with the decoder installed into the Locomotive and sitting on the track. But I also have had many occasions where the sound upload fails, sometimes corrupting the entire profile on the decoder stemming from this method. That's not always true. Dirty wheels or track are often blamed for bad uploads, but they are by no means the main culprit. I have seen issues with bad solder joints inside the Locomotive, clips that are loose on the trucks, ever so slightly corroded wires, many other small connectivity issues. To us big humans, these little things are, well, little, but they're detrimental obstructions for the data and the decoder. I've seen brand new locomotives where the sound file fails to upload, so this risk is not just for older units. So uploading sound files on the rail is a hit and miss, and usually fine for small adjustments. No worries, glad I could help, Canopy. So for me, I take the model railroader approach to patience and invoke my model railroader right. My railroad, my rules. So I will not and do not upload any sound files through the rail anymore. It's just not worth it to me. The setup I have here is for LokSound ESU, but when I change sounds for other branded decoders, I use a PR4 in exchange for the programmer you see here. However, the same principle applies if I'm testing or programming a Digitrax or Tsunami or any other type of decoder. So let's go ahead and do the quick test to see if the decoder is working. If it is, we'll move on with the install. So my first step is to install the smaller chip, which is the actual decoder, into the test stand. So the correct orientation of the chip is to have the chip hang over the edge. I then move over to the software. I click the programmer menu and select the read decoder option. If there's an issue, this is where it'll show up. Where the software reads address and has the value of 3, this is the road number that the decoder manufacturer set from the factory. I will change this later to match the cab number for the Locomotive. I go over the section named Driver's Cab, which is the section where all the testing is done. As I said before, this video is not intended to be in-depth, so click the notify bell if you want to see the video when I publish it. Off camera, I put the decoder through its paces for motor, lighting, and functions. The testing stand confirms the decoder is in working order. It plays the sounds and moves the onboard test motor. Since the decoder is verified working, next I'm going to go through and upload the new sound file and make the CV adjustments. To upload the sounds, are you ready? First I'm going to make my way up to the programmer menu, then click Write Sound Data, accept all the defaults, and start the process of uploading the new sound file to the decoder. New decoders will ask to update the firmware, so I will. It's almost always a good idea. Almost. In this case, it's a good idea. The firmware will go through an update process, and after that completes, the actual sound files will start uploading, as well as all the configurations, or CVs, that you see in the software, including the road number of the Locomotive. Once the new sound file and the new configuration CVs are finished uploading, please don't expect a flashing completed message or anything like that. The upload progress bar just disappears, like Houdini. Now we can make our way over to the driver's cab again and start testing the new sound file. I'm going to play a snippet from the Sound Decoder series that I'm making that involves this install. I hit go and let's see if we can hear it start. It's a different sound file. And make sure the motor works. And it is. Brake squeal works. Okay. And we'll shut that off. Alright, looks good. The part you just watched is a snippet from my new decoder series. So if you enjoy that sort of thing, smash that subscribe and notify. Now that the sound files and all the CVs are programmed and uploaded to the new decoder, I'm going to join the decoder to the adapter board. Now we're ready to install this decoder into the Locomotive. Well, that's all, folks. For this episode, I'll call part 6 a success. Everything went smoother than expected, which is both satisfying and slightly suspicious. I'm really pleased with the progress we made today. In part 7, we're going to fire up the soldering iron, start assembling some parts and pieces, and inch closer to the finish line, trying to convince myself that this was a good idea. If you're enjoying this build, hit the subscribe button, tap the notification bell, and keep an eye out for part 7 is right around the corner. Thanks for watching, and as always, happy railroading.